Good morning, friends and dear students. I am Dr. Dwivedhi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. As I am in the progress in my course Aircraft Systems, today I am going to take about flight control and fly-by-wire system. As you know that in my previous classes I have discussed in detail about the flight controls and something about fly-by-wire system also. This will also help further enhancement of the knowledge on these topics. Today I am going to discuss about these are the topics of the day, that is flight control surfaces of a commercial airplane, secondary flight control linkages systems, methods of connecting controls, push-pull control rod system, cable and the pulley system, high lift control system, slats or leading edge flaps, trim and feel and Q feel system. These things I am going to discuss and hope this will be very useful, because something here you will get a new things which is very essential to understand for any aeronautical engineers or any other engineers. In my previous class, I have discussed about these topics: flight control surfaces of a commercial airplane, secondary flight control linkages system, methods of connecting controls, push-pull control rod system, cable and pulley system, and you can see that few topics are here in this lecture also. So I will start with secondary flight control, because we have done a lot about the primary flight control system, and we know that the primary flight control systems are the mainly three, that is the elevator, aileron and the rudder. And if the aircraft is equipped with canard, then canard is also part of the primary flight control system. Other than these 3 or 4, others are the secondary flight control system, which I am going to discuss in this lecture, and this slide shows about the secondary flight control of the aircraft. We can see that flap control is deployed, and what is the flap? This I will show you here. I think it will be very much clear. Here, this is the flap. Flaps are always used to make or shifted downwards, and this downward motion will make lift high. So they will generate a high lift, and mostly they are used during the takeoff, less angle of attack, and during landing we take more angle of attack, because at that time we need the lift as well as the drag. But during the takeoff we are not interested to have more drag. But if we deflect flaps, lift will generate, and there will be always the induced drag, which is the lift dependent drag, so drag will also increase. So flap control is deployed during takeoff or landing, extends the flap section rearwards and downwards to increase wing area. So this you can see here, this is here increased, it is made downwards like this, it is coming out. The camber is also increased, so it is increasing the wing area, also the camber, and thereby greatly increasing the lift. So it is used to increase the lift for a given speed and drag during landing. Next is the slat control is provided by the several leading edge slats by extending forward. So if you see that this is the wing, at the leading edge some another like this, some airfoil will be extended. So this is called the slat. This slat also need to be controlled, as and when we want to extend this slat, we have some mechanism. Pilot has to operate, it has to press by electrically or the manually, it has to operate, then only this thing will come out. Either it is the flight control, the primary or the secondary, all has to be operated by the automatic control or the autopilot control, or by the manual by the pilot. So slat control is provided by several leading edge slats by extending forward. So if it is like this, from here to here, this will be extended, not only the one place. Okay. So speed brakes, this you can see here. Here is the aileron, this is the flap, these are the spoilers, these are track fairing, and this is called the ground spoiler. Okay. So here this speed brakes are deployed when all of the over-wing spoilers are extended together, which has the effect of reducing the lift as well as increasing the drag. So why we need the speed brakes? If aircraft is flying, we cannot apply the wheel brake on the air. So but how you are going to reduce the speed of the aircraft? That time, here some wings, some plates, this you can see here, these plates are made upward like this. Everywhere it is like this, it will come. So the air, it will give more resistance. So your aircraft speed will be reduced. But we cannot reduce the speed below the speed of the stall speed. Otherwise, aircraft will start sinking. So we should make sure that the speed breakers are used, or spoilers are used, and these are reducing the lift, and also decreasing the drag. But it should not reduce that much lift that it is less than the sustaining speed of the aircraft. Most air brakes are located on the rear fuselage, upper or the lower section, and may have a pitch moment associated with their deployment, controlled by automatic control of the system. So if we use this air brakes, the pitching motion will be there, and this has to be countered by automatic or autopilot. A fighter control surfaces are much greater than the corresponding control surfaces on an airplane. So the fighter aircraft, we have very much great efforts are required because it's very high speed aircraft, area is very less, so more efforts are needed for the secondary flight control to be operated. So now flight control linkages system. The pilot manual inputs to the flight control are made by moving the cockpit control column or the rudder pedal in accordance with universal convention. Pitch control is exercised by moving the control column fore and aft. Just I have told you, if you want the pitch, it has to go forward or the rear. So forward means nose down and rear means nose up. So pitch down and pulling the column aft, it gives the pitch up. Roll control is achieved by moving the control column. So if you see here, this is the control column. If I want to move, so pilot will move like this, aircraft will go. If I doing like this, it will go. If I want to nose down, it will keep nose down, aircraft will be nose down. If you want up, aircraft will go up. Okay. So yaw is controlled by the rudder pedal. Pushing the left pedal will yaw the aircraft to the left, while pushing the right pedal will have the reverse effect. So if you want to make your nose left or the nose right, so what you have to do? So pilot will sit here and it will apply its leg, feet. Push the left pedal by its feet, so it will go to the left. If he is pushing the right, it will go to the right, because the rudder will go in the same direction. If you are putting the right, this rudder will go in this direction. If you are putting left, it will go in this direction. It will move from here to here, and if you want to make a right, it will move in this direction. So like this, things are happening. Methods of connecting controls. There are presently two main methods of connecting the pilot control to the rest of the flight control, and these are the push-pull control rod system and the cable and the pulley system. So mechanical, these are the two mechanical systems by which we can connect the control from the pilot. So one is the push-pull control rod and another is cable and the pulley system. Here I am describing about push-pull control rod system. So here if you see that the trim actuator in tail pane, that is the pitch, this you can see here, trim actuator, rudder yaw and aileron roll control system, spring feel units in tail plane, pitch, rudder, and some spring field units are here. They will give the feel that pilot is operating and he is experiencing some pressure. Q field unit in the rudder, yaw control system, power control units for tail plane, rudder, and the aileron actuation. So here all these push-pull rod systems of different rods are shown here. Tail plane circuit, rudder circuit. So tail plane is different, rudder is different, and your aileron is different. So for every system we have the different linkages and different systems, and these are operated accordingly. So now slat are the leading edge flap. So this you can see here, it is a slat, or this is also called the leading edge flap. So what is the purpose and how it is working? This you can see here, and at the leading edge, just you can see, it is extended. 1, 2, 3, 4, 5, 10, 11, 12, 13. 13 slats are there. In this wing, 13 slats, and all will be operated by the help of the pilot. Slats are the leading edge devices on aircraft that enable higher angle of attack. Flaps are devices on the leading edge. It is called Kruger, and trailing edge, which increases camber and the depth of the wing. Slats create a slot between the slat body and the wing leading edge, so the air can pass from the bottom to the surface to hold off a stall to higher angle of attack. Flaps merely extend its fore and aft and direct the flow downwards for more lift. Both are mainly used in low speed situation of takeoff and landing. Trim and feel. Trim and feel devices. So how we can trim the aircraft and how the pilot will feel that how much he is operating. So that is the system which is called the trim and the feel arrangement. So trim and feel devices provides pleasant handling characteristics to the aircraft. It means the pilot will try to fly with a very good way. Okay, so here if you see, this is the stabilizer. Then we have it is a horizontal tail. Horizontal tail. This is the horizontal tail. Then we have here elevator. It is shown here, elevator. And after the elevator, we have the trim tab. Always the motion of the trim tab will be opposite to the motion of the elevator. And this makes the pilot a hands-free flying. Otherwise, if you don't have this trim tab, pilot has to hold the elevator in that situation. That is the objective of any trim tab or any feel unit. Pilot has to feel it. So this you can see here that lift for the maneuver and lift for the cruise. For the lift, for the cruise, we need this much. If you want to maneuver, this much extra feed is required. Weight is here. Trim and feel. Trim force, it is so we need the more trim force for the maneuvering. Initially only we want this much for this case, but as we increase this, lift will increase this much, we need this much extra maneuvering, and this maneuvering can be done by the help of your trim tabs and additional deflection of your elevator. Now what is the feel and how the pilot will experience this feel? The provision of artificial feel became necessary when aircraft performance increased to the point where it was no longer physically possible for the pilot to apply the high forces needed to move the flight control surfaces. Two types of feel systems are there. One is a spring feel and other is the Q feel. This I am going to discuss in this. So, to provision of artificial feel, you know that nowadays it is autopilot or hydraulically operated or electrically operated. Pilot will not experience that how much force my aircraft control surfaces are generating. It is very much essential that pilot or the person who is flying the aircraft, he or she should be able to feel how much aerodynamic forces and how much moment and inertia and other activities are taking place on the aircraft. So we need to understand and we need to assess. So this field is provided by two type of system. One is by the help of the spring and another by the help of the Q field. Q is what? It is a dynamic force. Pilot will experience a dynamic force. In the spring system, the spring is giving the feedback that how much your control is applied. Okay, so here I am discussing about spring field system, and here this you can see here it is a pilot stick. Pilot will move this stick left or the right. As he is moving, it will be transmitted to the your control surfaces. If I talk about the control surfaces, it is for the primary, elevator, rudder and ailerons. Okay, so it will give there, but some feedback you will get, some forces you will get. These forces will be transmitted to a spring to counter control input force. So whatever input you are getting, here the spring, this spring will counter. Airspeed and attitude data will be fed here, and accordingly pilot will experience how much force your aircraft is generating. That is the purpose of any field unit. So as pilot input a signal to deflect the control surface, the resistance of the spring is felt. So this spring will give the resistance. Greater the input, greater the resistance. So how much it is getting the input, that much resistance pilot has to feel. Effective at lower speeds where greater deflections are required. So this type of systems are very much useful for a low speed aircraft, not for a high speed aircraft. For high speed aircraft we need another type of system. That type of system I am going to discuss in my next slide. Now we can see here that Q field system. So what is the Q? Q is referred as dynamic pressure found by subtracting static pressure from the pitot pressure. So dynamic pressure means it is the total pressure minus static pressure. So you will get the dynamic pressure, that is called the Q. Pitot pressure directed at one inlet and static pressure in other, resulting in differential dynamic pressure which acts to bias the system. So in this what happened? Pitot pressure directed at one inlet and static pressure in other, resulting a differential dynamic pressure which acts to bias the system. Linear moment of piston leads to field resistance to pitot. The greater the moment, greater the field. So linear moment of the piston. So if you can see here is this piston. So this is called the linear moment. This linear moment of the piston leads to field resistance to pilot. This will give a field resistance to the pilot, although requiring only a small deflection. So in this way, here is the pitot and here is the static. So this difference will give the Q part. It is called the Q part. Accordingly, you will get here the difference forces you will experience here as per that. Now hydraulic Q field is here. So here this you can see here it is a pitot and here is the static. So pitot minus static, you will get the Q. Q is the dynamic, is equal to half rho V square. This your difference you are getting. This shaft is experiencing this Q. Okay, and here if you see it is a return line and this is the pressure line. Here is the servo valve and two powered by flying control, and here is a one again jack, and here you are getting here feel you are experienced by the pilot. Okay, so in this way Q field is working, and this is very important equipment, a very small equipment, but pilot will experience that, okay, how much the speed, how much the forces, how much the load your aircraft is experiencing, it has to be felt. Otherwise, now in autopilot, how the pilot will control? If anything is going wrong, pilot should feel. Pilot do not have any sensors, but autopilot has the sensors. This sensor will come by the speed and other activities, and it will be generated by the Q field system. This is shown here, a Q field unit of BAE GR5. The Q field unit is looking like this. This is a Q field unit of BAE GR5 AV8B. This is the aircraft name, and this is the all inlet, outlet, here electrical signals. These are all the atmospheric pressure ports, and here is the hydraulic ports. These all things are operated, and it is a very small unit, and this is giving the feel to the pilot. Power assisted flight control system. So another is by the help of the hydraulic power, how the this power is used to control the system. A system of flying control in which the force need to move the surface, although partly provided by the pilot effort, it supplemented by electrical, hydraulic or pneumatic means. In a power assisted flight control system, failures, the pilot will have some difficulty in controlling the aircraft. This was the system used in aircraft when power control were introduced, and it is no longer in use. Okay, so this is, it is return line, pressure line, trapped flight, piston attached to the control surfaces. Control surfaces are moving like this. So nowadays it is not used, but it was used rigorously before 30 years. Now next I am talking about the fly-by-wire. Okay, so in this fly-by-wire, it is shown for the normal loss. So fly-by-wire control loss. So what is the control loss of the fly-by-wire? Basic control loss alongside conditional algorithm help to detect failure and to revert the system to alternate law. And what is the alternate law? Basic control loss without any additional handling. In case of any further failure, it should revert to mechanical actuation. Direct loss, direct relation from control stick to the control surfaces. Here if you see here, it is a normal law. Most double failure, computer hydraulic ailerons. Then it goes to alternate law. In alternate law, if you can see here, it goes to the final failure, and it is a mechanical reversal. It is a direct loss. It's certain triple or double undetected failures are coming, and in this way we have the three types of laws. There is normal law, alternate law, and the direct law. Direct law means it is directly actuating. Normal law means it is some conditional. If this thing happen, what will happen? Alternate law, basic control laws without any additional handling. Alternate means if not fail, it will work. Like this, it will work. Here I have shown one fly-by-wire in Airbus. This contains the 7 computers. It is 2, 2 and 3. These are the 7 computers. 3 independent hydraulic power units. Here this we can see that there are 3 different power units are there. Electrical for most and mechanical control. We give this all things, and this all details are shown here, and hope it is very simple to understand, and different activities are shown here, and flight control systems of Airbus is depicted. Here, these are the references: Moir I and the Seabreeze A, aircraft systems, mechanical, electrical, and avionics systems, Professional Engineering Publishing Limited, London, and Bury St Edmund, UK, ISBN number 186058289 of 2001. Next is Moir I and Seabreeze A, Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. These are the two books from where I have taken this contents. So, any questions you are welcome to ask. My email for the is ydwivedi@gmail.com. This is my email. You can send me any query. I will be trying to reply your questions. Thank you very much for joining this class. Hope you will like and subscribe this channel, and it will be useful for the student of aeronautical engineering as well as in other branch of engineering. Thank you very much. I will be meeting in my next class. Till then, goodbye and see you.
Like, share and subscribe. Hit the bell icon for more updates.